Four-wheel drive vehicles. Rugged terrain. Weather at the extreme. Go anywhere capability. Four-wheel drive here is a necessity. With advances in technology, four-wheel drive systems are now beneficial for all driving situations, not only off-road, but on-road as well. The increasingly large numbers of four-wheel drives on the road today are giving their owners real performance and safety advantages. But how do customers sort through all the different types of four-wheel drive and find what's best for them? With all the marketing nomenclature, it can get very confusing. Despite the tantalizing titles, they don't give much clue to the system's capabilities. And there are differences. There are four types of four-wheel drive systems: part-time, full-time, permanent, and all-wheel drive. That's it. Even with all the fancy names, it comes down to just these four. An understanding of these four types of systems will lead to informative discussions with customers and demonstrate that Land Rovers have a superior four-wheel drive system. We'll explain the four systems. Once you understand what they do, the advantages of some of these systems will be clear. First, it's important to understand the basics of four-wheel drive. Simply put, four wheels grip better than two. Four-wheel drive makes better use of the vehicle's available power. By directing power to all four wheels rather than just two, as in a two-wheel drive vehicle, a four-wheel drive equipped vehicle assures that there will always be a powered wheel with grip. The basic driveline components of any vehicle, two-wheel drive or four-wheel drive, are the engine, transmission, and driven axle with a differential. In many cases, four-wheel drive is provided through the addition of a secondary transmission, called a transfer gearbox or a transfer case. Here's how it works. The engine produces power that is sent to the transmission. The transmission contains a series of gears which allow the engine to operate in its optimum power band at various road speeds. In a two-wheel drive vehicle, the transmission sends power directly to the driven axle, front or rear, depending on the layout of the vehicle, whether it is front or rear-wheel drive. The driven axle splits power to both wheels through a collection of gears called the axle differential. The differential also performs another function. It permits each wheel to turn at a different speed. As a vehicle goes around a corner, the wheels on the outside travel faster than the wheels on the inside. Without the differential to allow this speed difference, the inside and outside wheels would fight each other, causing adverse handling, excessive tire wear, and possible damage to the drivetrain components. While the differential allows smooth operation when cornering on-road, in low traction situations it sends power to the wheel with the least resistance or least traction. Here's where the benefits of four-wheel drive engineering become apparent. By adding a transfer gearbox between the transmission and drive lines, the power is transferred from the transmission to both the front and rear axles. The vehicle now has four-wheel drive capability. Most 4x4s are equipped with a two-speed transfer gearbox, which provides a high gear or high range for normal on-road driving, and a low gear or low range for slow-speed off-road driving. Think of high range as top gear on a bicycle. It provides speed but makes hill climbing difficult. Low range is similar to low gear on a bicycle. It provides plenty of power for hill climbing, but only at low speeds. Four-wheel drive systems, four components: engine, transmission, axles with differential, and transfer gearbox. The combination creates a four-wheel drive system. Now we'll take a look at the four types of four-wheel drive systems: part-time, full-time, permanent, and all-wheel drive. There are significant differences when it comes to convenience and benefits to the driver. In the early days of four-wheel drive, vehicles were viewed as tools or pieces of equipment. These vehicles had part-time systems. That meant they used two-wheel drive for paved surfaces and four-wheel drive anywhere off-road or in very slippery conditions. There are many vehicles with part-time systems around today, some old and some new. Part-time systems are very robust and inexpensive, and the four-wheel drive feature can only be used off-road or in very slippery conditions. In these conditions, with four-wheel drive engaged, the front and rear axles are mechanically locked together, and power is split 50-50 front and rear. This provides power to all four wheels, giving the four-wheel drive traction needed for loose and slippery surfaces. But vehicles with part-time systems cannot be driven on pavement in four-wheel drive. In four-wheel drive, the front and rear wheels cannot turn at different speeds. If driven on pavement in four-wheel drive, driveline windup would occur, stressing driveline components and creating handling problems. Perhaps the biggest limitation with the part-time system is that the driver must decide when to choose two- or four-wheel drive. In addition, with some vehicles, changing from two- to four-wheel drive is a bit labor-intensive. Stop. Get out and lock the front hubs, essentially locking the front wheels to the front axle. Get back in and shift from two-wheel drive to four-wheel drive with the transfer gearbox. The front and rear axles are now locked together. And of course, switching back to two-wheel drive is equally complicated. Part-time systems are still available today. However, the manually locking hubs have given way to automatically locking hubs, and the process is much simpler. Simply pulling a lever locks the hubs and engages four-wheel drive. There is no need to stop. This is where the term shift on the fly originated. Shift on the fly means the vehicle is shifted from two-wheel drive to four-wheel drive in high range only. Other part-time systems use electronics to make the shift, relegating everything to a button on the dash. Even though these methods make it easier to invoke four-wheel drive, all these vehicles have the same part-time system, which does not permit the use of four-wheel drive on dry pavement without risking wear and tear on tires and driveline. In addition, part-time systems can be intimidating to new users who must know when and when not to engage four-wheel drive. Because there are advantages of four-wheel drive on pavement, and part-time systems have limitations, many newer sport utilities have a more advanced four-wheel drive system called full-time. Manufacturers have added components in the transfer gearbox, such as a center or third differential, or limited slip device, such as a viscous coupling unit or electronic multiplate clutch. By selecting four-wheel drive or auto four-wheel drive mode, depending on brand, these permit front and rear axles to rotate at different speeds to allow use of four-wheel drive on pavement all the time. Thus, the term full-time, providing handling and safety advantages on dry roads as well as in slippery conditions. For off-road use, four-wheel high lock or four-wheel low lock should be selected to provide additional traction. When in a locked mode, four-wheel drive cannot be used on dry pavement. Many full-time systems evolved from the part-time design and still provide a two-wheel drive mode. Two-wheel drive is thought to provide better fuel economy and less wear and tear on the vehicle. Land Rover engineers compared fuel economy between two- and four-wheel drive and found a negligible increase in fuel consumption when four-wheel drive is engaged. In fact, there are fuel-efficient vehicles such as Volvo, Audi, Subaru, and the Land Rover Freelander, which operate in four-wheel drive all the time. Unlike these cars, sport utilities are less fuel efficient due to their shape and bulk, not because of four-wheel drive. And wear and tear is not a concern because the system has components which are meant to be used and last the life of the vehicle. Operating in two-wheel drive will not necessarily save on wear and tear. In fact, two-wheel drive operation requires certain components to work harder because all power goes through the rear wheels. In four-wheel drive, wear and tear can actually be less because engine power is spread over four wheels instead of two. At best, a full-time system is a compromise because it must work in both two- and four-wheel drive. Permanent four-wheel drive takes the full-time concept one step further. Two-wheel drive is not an option. The driver does not have to decide which mode to select. Four-wheel drive is engaged permanently through the use of a viscous coupling unit, or VCU, center differential, or both. Power is now capable of being distributed to all four wheels. There are many benefits with permanent four-wheel drive. On dry roads, it improves handling, braking, and overall control. As weather and road conditions change, permanent four-wheel drive is ready. There is no decision to engage and no question that it is functioning. As with full-time systems, permanent systems require a way to control the power balance between front and rear axles. Remember, in a full-time system, for additional traction off-road, the transfer box must be locked in either four-wheel drive high lock or four-wheel drive low lock. When locked, full-time and permanent systems split power output 50-50 to the front and rear axles. This gives the same effect of a part-time system when four-wheel drive is engaged. When locked, these vehicles should not operate on pavement, but their four-wheel drive systems are providing the maximum traction available for off-road use. Some permanent systems, such as Range Rover, use a VCU to control power output automatically. Others, like Discovery Series 1 and Defender, use the driver-selectable differential lock, or diff lock. Both of these systems limit the amount of slip by the center differential. Just as the axle differential allows left and right wheels to rotate at different speeds when cornering, the center differential allows the front and rear axles to turn at different speeds. This allows four-wheel drive to operate smoothly on road. Unfortunately, in slippery conditions, the axle differential allows the wheel with the least traction to spin. The center differential operates in the same way, by sending power to the axle with the least traction. In this case, all power goes to the rear axle. Four-wheel electronic traction control, a viscous coupling, or manual mechanical lock on the center differential prevent the differential from sending all available power to the spinning axle. Diff lock requires activation by the driver, while the VCU and/or electronic traction control slip automatically. Land Rover's permanent systems use a center differential in the transfer gearbox to distribute power evenly to the front and rear axles in dry, high-traction conditions. Four-wheel electronic traction control, a VCU, or mechanical center diff lock are used to keep the power output even between axles in slippery conditions. Other vehicles with permanent four-wheel drive, such as Toyota Land Cruiser and Lexus LX470, are similar to Land Rover systems. Jeep Grand Cherokee with Quadra-Track or Quadra-Track 2 uses a VCU or a gyro disc, but lacks a center diff. Although the driver cannot select two-wheel drive, these permanent systems direct most of the power to the rear wheels during normal driving. Jeep's permanent systems are activated when wheel slip is detected, causing a speed difference between front and rear axles. The VCU or gyro disc automatically transfers power to the front wheels to help regain grip. Optional Quadra Drive adds a gyro disc to each axle differential on the latest Grand Cherokee, limiting wheel spin at each axle, providing even more grip and control. Range Rover and Discovery Series 2 take advantage of their advanced ABS systems to provide additional grip through the use of four-wheel electronic traction control. By monitoring wheel speed using ABS sensors, four-wheel electronic traction control senses wheel spin and automatically applies the brake to the spinning wheel. This slows the wheel without traction and transfers power through the axle differential to the wheel with traction. Range Rover has used electronic traction control for rear-wheel traction control since 1993. Both Range Rover and Discovery gained the added performance of four-wheel electronic traction control in 1999. Four-wheel electronic traction control assures that as long as one wheel has traction, forward progress can be made. Different levels of four-wheel electronic traction control are becoming available on other sport utilities. Mercedes pioneered four-wheel electronic traction control on the M-Class, but with a bias toward on-road control. Toyota, Lexus, and even Hummer are employing four-wheel electronic traction control to increase off-road capability with these user-friendly systems. Viscous couplings, gyro discs, and four-wheel electronic traction control provide extremely capable, easy-to-use, durable four-wheel drive systems. There is a trend to incorporate some of the features of permanent four-wheel drive systems into on-road vehicles. This is called all-wheel drive. Like permanent four-wheel drive, all-wheel drive offers no two-wheel drive mode. All-wheel drive improves performance and handling on-road and provides great all-weather performance. The difference between permanent and all-wheel drive centers around their intended use. All-wheel drive vehicles have no low-range capability and are not designed for heavy off-road use. In general, all-wheel drive vehicles provide all-weather rather than all-terrain capability. Some all-wheel drive systems have the most advanced four-wheel drive technologies, such as four-wheel traction control and viscous couplings. Vehicles incorporating all-wheel drive often provide plenty of traction, but are limited by ground clearance and the overall packaging of the vehicle. Again, these vehicles are intended to get through all weather conditions and perform well for light-duty off-roading. Part-time, full-time, permanent, and all-wheel drive. The four types of four-wheel drive share a common theme. They all make better use of a vehicle's power by distributing that power through all four wheels. But they all do it in a different way and with different intentions. Part-time systems offer an inexpensive four-wheel drive system, although limited to off-road use. Operation can be complicated and may intimidate someone new to four-wheel drive. Full-time systems provide the enhanced on-road performance of four-wheel as well as off-road capability. Full-time systems have a two-wheel drive mode. The combination of on-road operation in either two- or four-wheel drive may prove a compromise in handling, performance, and possibly durability. Permanent four-wheel drive is purpose-built to provide the best traction available in all conditions, both on and off-road. No driver input is required for the vehicle to perform at its best. All-wheel drive is similar to permanent four-wheel drive, but it is not designed to go off-road in severe terrain. With no low range and typically packaged in a road car platform, all-wheel drive is intended to increase on-road performance in all weather conditions, with limited off-road use. All-weather rather than all-terrain. When sizing up a four-wheel drive system, keep in mind how easy it is for a driver to use and the benefits received from its use. Can it be used all the time? Is it simple to use? Or better yet, seamless? When a customer is looking for a 4x4, the best choice is a Land Rover, with four-wheel drive available at all times, whether permanent or all-wheel drive. It's never necessary to know when or how to engage, providing real safety, handling, and performance benefits. And best of all, it's engineered to go just about anywhere, no matter what the weather.